Our lesson today is on adding and subtracting expressions, and it's really going to tie together all of what we've been doing with our work with expressions. We're going to first be able to translate our problems algebraically, and then we're going to use our skills of combining similar terms in order to come up with a simplified expression. And so in the first example, we're told that Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? Okay, and so we've got the Rudy's Rock Climbers, which is a $65 initial fee and a $40 monthly fee. And then there's the Ace Health Club, which has an initial fee of $80 and a monthly fee of $50. And so I think the first thing that's going to be important to do is figure out the monthly cost at each place. So let's start with Rudy's, the rock climbing place. Okay, for Rudy's, you're going to pay $65 initially, and then you're going to pay $40 each month. Okay, so you have to pay a one-time fee of $65. So I'm going to start with $65, that's the initial fee. And then I'm going to have to pay an additional $40 each month. So I'm going to add 40 times M, because we have to pay $40 for each month that we remain with the rock climbing club. So this is the expression that represents the monthly cost for Rudy's. We're going to do the same thing for Ace. Okay, this is the health club. And here you have an initial one-time fee of $80, so we'll start with 80, plus then a monthly fee of $50, so plus $50 per month M, 50 times M. And so this is the expression for Ace, $80 plus $50 times M months. So now what we want to do is find her total fitness cost after M months. We know what she's going to pay individually at each place. To get the total cost, I'm going to have to add these two expressions together. So I'm going to take my Rudy's 65 plus 40M, and I'm going to add that to Ace, which was plus $80 plus 50M. Okay. I'm going to rearrange my terms. I like my variable terms first, 40M plus 50M plus my constant 65 plus 80. And now I'll combine my similar terms. 40M plus 50M is 90M plus 65 plus 80. And then when I combine the initial fees, the constants, I'm going to have 90M plus 145. And so this expression right here represents Delilah's total monthly cost after M months, 90M plus 145. In example 2, we're told that Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. Okay, we're trying to find Cindy's profit. And the way that you find profit is taking the amount of money that you earn and subtracting off the amount that you have to pay for the expenses. Okay, and so we've got two different foods. We've got muffins and bagels, and let's figure out what the profit's going to be for each type of food. So we'll start with the muffins. Okay, muffins. She sells muffins for $2.40 each. So each muffin M that she sells, she's going to get $2.40. So she's going to earn $2.40 times M muffins. Okay, so this is going to represent the amount of money that Cindy earns by selling muffins. Then we have to subtract off her expenses to figure out what the profit would be. Cindy spent $125 on ingredients for muffins. So we're going to take the amount that she earns and subtract $125. And however money was left over would be what the profit would be. So the expression to represent the cost or the profit for muffins is $2.40 M minus 125. For bagels, okay, we see on the sign that you pay $1.80 for each bagel. So she's going to earn $1.80 for each bagel B, $1.80 times B for each bagel. And now we have to subtract off the cost of the ingredients. And for the bagels, she spent $92.40 on those ingredients, so minus $92.40. Okay, and again, we want to know what her total profit is going to be, so I'm going to take the profit from the muffins and add the profit from the bagels. So I'm going to have $2.40 times M minus 125, which was the profit for the muffins, and I'm going to add $1.80 B minus 92.40, which was the profit for the bagels. Rearranging our terms, all right, I'm going to put my variable terms first alphabetically. I have $1.80B plus $2.40 M minus $125 minus $92.40. I can't combine my variable terms since they're not similar to each other. Bagels and muffins aren't similar to each other, but I can combine my constants. Negative 125 and negative 92.40, those are same signs, so you're going to add them together. So I'm going to have $1.80B plus $2.40 M. And then when I combine negative 125 and negative 92.40, that gives me negative 217.40. So I'm going to write minus $217.40. And this expression is going to represent Cindy's profit for selling M muffins and B bagels. In example 4, we're told that Leah's family wants to put a tiled border around their swimming pool. Write an expression that represents the total area of just the border. Okay, so we see that we've got a rectangle, a smaller rectangle inside, which is the pool, and then the bigger rectangle going around it is the tile border with the pool. And our process for finding just the area of the border here is going to be able to find the entire area of the border and the pool, and then subtract out the area of the pool. So let's start by finding the total area, Okay, well, the shape is a rectangle, and we've talked about this before. In order to find the area of a rectangle, you have to multiply the length by the width. And if we look at our dimensions of the pool right here has a length of 14 feet. And if I include the border, I can see here that the border is 2 feet on each side. So to go from this corner all the way to this corner over here, I know I'm going to have a length of 14 feet for the pool, plus an extra 2 feet here for this side of the border, plus an extra 2 feet here for this side of the border. 14 plus 2 is 16, plus 2 is 18. So it's got an entire length of 18 feet. And then we also have to figure out what the width is going to be. So from this corner down here, all the way to this corner up here. And if I look at the width of the pool from here to here, they've labeled it as 2x plus 14 feet. Okay, so from here to here on the pool is 2x plus 14 feet. But when we add the border on, I'm going to have another 2 feet here, plus another 2 feet here. So these constants are going to have to get added to the constant that we find right here. So the width of the pool is 2x plus 14, plus 2 more from this part of the border makes it 2x plus 16, plus 2 more for the border here makes the total width 2x plus 18. Okay? So those are the dimensions that we're going to be working with. We have a width of 2x plus 18 feet, and we have a length of 18 feet. And so now what we want to do is figure out what the total area is going to be. So I'm going to have to multiply those values together. So let's take the length, which was 18, and multiply that by the entire width. So I'm going to put the entire width in parentheses, which is 2x plus 18. In order to figure out what this is going to be, I'm going to use the distributive property. 18 times 2x plus 18 times 18. 18 times 2x is 36x, and 18 times 18 is 324. So the total area of the pool and the border is 36x plus 324. Now we're going to get the area of the pool. Area of the pool. Okay, and we already talked about the dimensions of the pool. It had a length of 14 feet and a width of 2x plus 14 feet. So it's rectangular. I'm just going to multiply the length by the width. So I'm going to do 14 times 2x plus 14, which was the width. Put that in parentheses. And now we'll go ahead and distribute here 14 times 2x plus 14 times 14. Okay. 14 times 2x is 28x, and 14 times 14 is 196, plus 196. So this is the area of just the pool. To get the area of the border, okay, for just the border, I'm going to take the total area and subtract off the area of the pool. Okay, so this was the total area, 36x plus 324. 36x plus 324. I'm going to have to take that entire area and subtract off the area of the pool, which was 28x plus 196. Okay, and I put it in parentheses because I've got to take this total area and subtract off this area of the pool. So remember what we have here, all right? In front of this set of parentheses, there's a 1. And in front of this set of parentheses, that's really a negative 1 right there. So I'm going to have to distribute 1 to these terms, which isn't going to change anything, 36x plus 324. But then I'm going to have to distribute a negative 1 to each term inside of this parentheses. Negative 1 times 28x is negative 28x. And negative 1 times 196 is negative 196. So now I'm going to rearrange my terms. 36x minus 28x plus 324 minus 196. Okay, and now I'll combine my similar terms. 36x minus 28x, that's going to leave me with 8x plus 324 minus 196. And I'll just bring this over here. When I do 324 minus 196, that's going to leave me with 8x plus 128. And so this expression right here represents the area of just the tile border. In example 5, I'm going to take this entire first expression and I'm going to subtract off this entire second expression. So just like in the last example, there's a positive 1 in front of the first set of parentheses, which isn't going to change the terms at all. 95 hundredths x minus 4 hundredths. But with my second set of parentheses, this is a negative 1 that I'm going to have to distribute. Negative 1 times 99 hundredths x is negative 99 hundredths x. Negative 1 times negative 13 hundredths is positive 13 hundredths. Now we'll go ahead and rearrange our terms. So we're going to have 95 hundredths x minus 99 hundredths x minus 4 hundredths plus 13 hundredths. When I look at my variable terms, these are different signs, so I'm going to subtract. All right, 99 hundredths minus 95 hundredths leaves me with 4 hundredths x. And we have to keep the negative symbol since negative 99 hundredths x has the bigger absolute value. Bring down our constants. And now when I combine the constants, again, these are different signs, so I'm going to subtract. So I'm going to have my negative 4 hundredths x. Okay. 13 hundredths has the bigger absolute value, so I'm going to keep it signed, so plus. And now when I subtract 13 hundredths minus 4 hundredths, that leaves me with 9 hundredths. And so this expression is the answer after we do the subtraction. In example 7, I'm going to take this entire first expression and subtract off the second expression. So I have a 1 in front of the first set of parentheses, a negative 1 in front of the second set of parentheses. These first three terms are going to stay the same. 17 plus 4.5m plus 8k. But each of these second terms is going to change to their opposite when I multiply by negative 1. So that's going to be minus 7.5m plus 9 minus 4k. Rearranging our terms alphabetically, we're going to have 8k minus 4k plus 4.5m minus 7.5m plus 17 plus 9. 8k minus 4k is 4k. 4.5m minus 7.5m, different signs. The negative signs got the bigger absolute value, so minus 7.5m minus 4.5m is 3m. And then 17 plus 9, same signs will add. This is going to leave us with plus 28. So we get 4k minus 3m plus 28.